Okay, so where we left off, we've done some algebraic substitution there. Let's come over here and do some algebraic substitution. Again, we'll drop that. That's not very helpful. Give us a little more space. Ramp on cart minus. Now here we can do a substitution again, where we can say that's going to be WEC cosine 34 degrees. You can go back to the previous video to see that. And you can see it up here if you'd like. Well, remember, our goal is to find the acceleration of the cart down the ramp. That's this quantity right here. And so ultimately, we're going to have to get a lot more things substituted in. Some of you may at this point be worried that we don't have the mass of the object. But you're going to see a pretty neat thing that when algebraic substitution is used, we get around that problem. So let's go ahead and continue. Now, over here, the acceleration along this y-axis here is 0. The thing is not speeding up or slowing down in either of those directions. And so that's 0, which means the whole side of this, no matter what the mass is, that whole quantity there is 0. 0 times anything is 0. That means the normal force ramp on cart minus earth on cart cosine 34 degrees is equal to 0. And normal force ramp on cart must be equal to, I'm just going to pull this over to this side, earth on crate times cosine 34 degrees. Well, that's great because I want to find this, and one of the things I don't know is the normal force, but now I have an expression for the normal force. So that's going to be mu times, now wherever I have normal force here, I can plug in that because they're equal. So this will be WEC cosine 34 degrees minus WEC sine 34 degrees equals MAX. This piece here came from here. It still doesn't look like we can get to a solution, except that we also know, we do this in blue, that the weight of the object, earth on crate, is equal to G times M. And so wherever I have a weight, I can insert G times M. Let's see that here. Minus mu. Wherever I have weight, I can insert G times M. Cosine 34 degrees minus G times M sine 34 degrees equals MAX. Now, if you're super clever with math, you'll notice that M is in this term, M is in this term, and M is in this term. So dividing the whole thing through by M should eliminate M as a factor. I'm going to take all of this and reduce it, give myself a little bit more room to work now. All right, so I'm going to do that, and what do I end up with is minus mu times G cosine 34 minus G sine 34 equals AX. Now, our goal was to find the acceleration, and now look at here. We have G, which is a constant, 34 and sine of 34 are both numbers, and mu is a number. So we've got our answer pretty much right here. I'm going to substitute the numbers in and get the answer and show you that. All right, so after subbing in, the acceleration of x is 3 meters per second squared. And I just realized, and you probably realized too, that all of these should be pluses, but I don't have time to go back and change that, so I'll just change it right here. Anyway, there's your answer. Hopefully you've seen some algebraic substitution and how to work with situations where the object doesn't move horizontally or vertically, but rather on an incline. Okay.